Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Monday's mineral. This is sphalerite, commonly called zinc blende. It is a zinc sulfide with the chemical formula ZnFeS. It was discovered in 1847 by German geologist Ernest Friedrich Glocker, and he based the name off of the Greek word sphaleros, which means deceiving because it was difficult to identify. Sphalerite comes in a variety of colors, including brown, yellow, blue, red, green, black, and even colorless. So, color is maybe not the most useful way to identify this mineral. Its crystal habit is euhedral to granular with simple contact twins or complex lamellar twins. It is most recognizable by its perfect dodecahedral cleavage, for all you dice lovers out there. It fractures unevenly to conchoidally and is quite brittle, which is a shame because it is very highly sought after by gemologists for its high dispersion. Which means it creates rainbows when it's cut like this. And it's 3 times the dispersion of diamonds, so it's like super colorful. However, it's really hard to cut without it powdering, so this is rare. That being said, its hardness is between 3.5 and 4, so it's right in this area here, between calcite and fluorite. So it's about the same hardness as a copper penny. Woo! Its luster varies from adamantine like this one, to resinous like this one, to greasy like this one. And it has a brownish white to pale yellow streak, though some darker varieties, such as this one, will have a more reddish-brown streak due to the iron that replaces the zinc. So the pure zinc varieties typically are transparent to translucent like this crystal, but in its iron form it is typically opaque. And all of the varieties have a specific gravity between 3.9 and 4.2. Like other sulfide minerals, sphalerite forms due to volcanic activity. There are several types of deposits that it can be found in. One is sedimentary exhalative, which is a stratiform lead-zinc sulfides that form on the seafloor near volcanic vents, like this piece here. Metals precipitate from hydrothermal fluids and settle in shales, carbonates, and organic-rich siltstones in back arc basins or failed rift basins. Similar to that are the Mississippi Valley type deposits. This is the replacement of dolostone or limestone by ore rocks in platforms and foreland thrust belts. Sorry to interrupt, but do you like what you're seeing so far? Excellent. You can help me make more videos and improve the quality in 2 ways. One is that you can check out my Etsy shop where you can get cool swag like this t-shirt and other cool things with this fun logo on it. The second is to join my Patreon. I have a lot of cool things planned out, like reaction videos, parody songs that I've been working my butt off to write, a video on the geology of north central Montana that we teach to all of our participants who dig with us at the Montana Dinosaur Center. You should totally join us next summer. It's so much fun. And Minerals, Rocks, and Fossil Talks Junior for all your kiddos at home. Plus, you join the Patreon, you'll be able to join me on Discord, where you can see all the new papers in the field that are published all the time. And you'll be able to make video suggestions, get access to short college-level geology classes, and so much more. So, seriously, help me out. Check them out. Okay, back to your normal programming. The last way is through volcanogenic massive sulfides, where sulfides are leached out of volcanic rocks by hydrothermal fluids and deposited en masse on the surface of the ocean floor. So, lots of water involved. The top producers of sphalerite include the US, Russia, Mexico, Germany, Australia, Canada, China, Ireland, Peru, Kazakhstan, and England. Sphalerite is mostly used as an ore rock for zinc. 95% of the world's zinc comes from this mineral, and zinc is pretty useful. We certainly wouldn't have brass without it, or pennies for that matter, but those really aren't terribly useful anymore, unless you're like a collector. Due to sphalerite's variable trace element, it is also useful for extracting other metals such as cadmium, gallium, germanium, and indium. And as you notice, they're all shiny silver metals, so who can tell the difference? Unless you know what to look for. All of those metals may replace some of the zinc pieces, so occasionally you'll get trace amounts of these metals in your rock. But yeah, that's sphalerite. Shiny pretty rocks that are very brittle. Thanks for coming to today's lesson. Make sure that you tune in tomorrow for some fun trivia on sphalerite. And I will fossilise later.